375 degrees. Hot oil does not negotiate. 30 seconds too long and you don't get a donut. You get a dry ring of regret. 30 seconds too short and the center collapses. Oil temperature, batter hydration, proofing humidity, glaze viscosity. Fried dough looks simple. It isn't. At scale, a donut is a timing equation. Scale changes the rules. Dunkin' serves mornings in more than 13,000 locations worldwide. Every sunrise triggers the same demand. Fresh, warm, identical. But dough is alive. Oil drifts under load. Humidity changes with seasons. And customers don't care about variability. They expect sameness. The challenge isn't frying dough. The challenge is controlling heat, fermentation, and finishing at speed across thousands of kitchens. Morning traffic doesn't wait for chemistry. Chemistry must adapt to traffic. Failure at scale. If cake batter sits too long, leavening gases escape. Texture tightens. If yeast proofing extends too far, structure weakens. The ring deflates in oil. If oil temperature drops after repeated batches, crust absorbs excess fat. Greasy surface, dull color. If glaze cools before coating, it streaks. If glaze is too thin, it runs. If too thick, it clumps. In donut production, seconds are ingredients. Timing is flavor. Inside the system. Today we're stepping inside the Dunkin' Donut machine. Cake donuts, yeast donuts, munchkins, crullers, and the final finishing stage, where fried dough becomes brand identity. Because the donut is not complete when it leaves the fryer. It becomes recognizable when it's coated. Variety, the psychological engine. Mid-20th century America didn't run on donuts automatically. It ran on choice. Display cases filled with dozens of varieties triggered a decision pattern. If one looks good, 3 look better. Variety increases purchase volume, but variety increases complexity. Different shapes, different batters, different fry times, different finishes. So the system had to absorb variety without increasing chaos. Choice became the marketing hook. Process made it scalable. 3 production models. Dunkin' stores operate under 3 supply systems. Some mix and fry donuts in-store daily. Some receive fresh donuts from regional production facilities. Some rely on frozen batches reheated on site. Different logistics. Same requirement. Consistency on a clock. The customer cannot detect which model supplied the donut. That invisibility is engineered. 2 foundations. Cake versus yeast. Every donut begins with one of 2 bases. Cake or yeast. Cake donuts are chemically leavened. Fast, dense, stable. Yeast donuts are biologically leavened. Light, airy, variable. In manufacturing terms, cake is speed and control. Yeast is texture and risk. Cake donuts, speed through chemistry. Cake batter starts with water and proprietary premix, flour, sugar, dairy solids, egg powder, salt, spice calibration. Chemical leaveners activate once hydrated. There is no fermentation window. There is only a usage window. Once mixed, the clock starts. Wait too long and gas escapes. Structure collapses before frying. The batter loads into a plunger depositor. Uniform rings drop into oil at fixed intervals. 375 degrees Fahrenheit. Hot enough to set exterior quickly. Exterior crust forms. Interior moisture converts to steam. Steam expands internal cells. Under 2 minutes. Flip, finish, remove, assembly line frying. Metronome precision. Same drop rate. Same oil temperature, same dwell time. Repetition builds reliability. Oil, the active medium. Oil is not passive. Each batch releases moisture. Moisture lowers temperature. Temperature drift changes color development. Oil absorbs particles. Particles darken over time, so filtration runs continuously. Temperature sensors recalibrate burners automatically. Because frying is a chemical reaction. Maillard browning depends on heat and time. Too light and flavor is weak. Too dark and bitterness rises. Golden brown is not aesthetic, it's a calibrated endpoint. Munchkins, geometry shift. Munchkins use the same cake batter. Different nozzle. Multiple small deposits per cycle. Smaller mass changes thermal behavior. Higher surface area to volume ratio. They cook faster, but float unpredictably, so frying screens hold them submerged briefly. Uniform exposure, uniform color, what began as a byproduct, donut centers, became a standalone product line. Waste converted into revenue. Geometry creates opportunity. French crullers, steam engineering. Crullers shift the physics entirely. shoe-style batter, higher egg content, more moisture. When dropped into oil, steam expansion drives structure. No yeast, no chemical leaveners, just water converting to vapor. Steam inflates internal cavities. Light shell, tender interior, longer fry time, same oil temperature, different expansion mechanics, same fryer, different science. Yeast donuts. Controlled fermentation. Yeast dough begins with premix and active yeast. Water hydrates flour proteins. Kneading develops gluten. Gluten traps carbon dioxide. First proof begins. Warm, humid air, controlled environment. Yeast metabolizes sugar. Gas forms slowly. Structure builds gradually. Time determines texture. Too short and crumb is tight. Too long and structure weakens. After first proof, dough is sheeted to thickness. Thickness defines final rise potential. Cutters stamp concentric rings. Hole and ring in one motion. Efficiency through geometry. Second proof begins. This is the critical stage. About 45 minutes. Temperature and humidity precisely managed. Humidity prevents surface drying. Dry surface restricts expansion. Underproof dough shrinks in oil. Overproof dough collapses. Fermentation is biology constrained by engineering. Yeast frying. Locking structure. Proofed rings enter 375 degrees Fahrenheit oil. Exterior sets quickly. Interior gas expands further before final stabilization. Short-timed fry. Flip, finish, remove. Unlike cake donuts, yeast donuts continue expanding in oil. Timing is tighter. Excess seconds increase oil absorption. Shortage reduces structure development. Yeast donuts are not fried by instinct, they are fried by schedule. Powder, frosting, sprinkles. Powdered donuts tumble in rotating drums. Full coverage through motion. Cinnamon sugar relies on surface oil for adhesion. Frosted donuts invert. Top surfaces dip cleanly. Flip back upright. Sprinkles applied before frosting sets. Timing determines adhesion. Too early and sprinkles sink. Too late and they bounce off. Decoration is applied in seconds. Precision disguised as fun. Quality control. Visible metrics. Donut quality is visible immediately. Color reveals oil stability. Rise reveals proof control. Surface gloss reveals glaze viscosity. Texture reveals timing discipline. The display case is a final inspection window. Customers judge before biting. This is not just frying dough, it's compressing chemistry into a morning window. Hot oil does not forgive. Yeast does not rush. Sugar does not crystallize on command, unless the system forces it to. At scale, sweetness is engineered, because in the end, a donut is not just breakfast, it's controlled heat, managed biology, and timed sugar moving at sunrise speed. Behind every familiar morning ritual, there's a machine keeping time.